When establishing temporary power across a street, several options exist. Firstly, explore the possibility of an underground temporary connection. Contact the power company to inquire if they can provide a temporary underground connection across the street. This option, if feasible, can be less costly and less disruptive compared to erecting power poles. Secondly, consider a temporary aerial service drop cable supported by a messenger cable strung across the street. To implement this, install a temporary pole on one side of the street and attach the messenger cable to it. Run the service drop cable from that pole across the street to another temporary pole on the opposite side. This aerial method is often less expensive than setting up permanent power poles. However, be aware that it might necessitate approval from the municipality or local authorities. Safety is paramount in any temporary electrical setup. Ensure that all temporary connections strictly adhere to all relevant electrical codes and safety regulations. Permitting is another crucial aspect. Obtain all necessary permits from the municipality or local authorities before commencing any work, whether it involves setting power poles or installing any form of temporary connection. Cost is also a major consideration. Carefully evaluate the costs associated with each option, taking into account materials, labor, and permitting expenses. Regarding a recommendation, firstly investigate the underground temporary connection option. If underground is not a viable solution, then consider the aerial temporary service drop cable, ensuring it's properly supported by a messenger cable. It is highly recommended to contact a licensed electrician. Seek their professional advice and assistance throughout the installation and permitting procedures. This ensures compliance with the regulations and safe implementation of the chosen solution. When considering an underground temporary connection, remember these factors. The depth of the trench must comply with local electrical codes, typically requiring a minimum depth to prevent accidental damage. The type of cable used for the underground connection must be suitable for direct burial and rated for the appropriate voltage and amperage. Proper backfilling of the trench is essential to protect the cable from physical stress and damage. Furthermore, marking the location of the underground cable with warning tape or other indicators is important to prevent future excavation damage. In the case of an aerial temporary connection, the following aspects are crucial. The height of the temporary poles must be sufficient to provide adequate clearance above the street and any other obstacles, adhering to local regulations. The messenger cable must be strong enough to support the weight of the service drop cable and withstand wind and ice loads. The service drop cable must be properly insulated and protected from abrasion and environmental factors. Securely attaching the cables to the poles using appropriate hardware is crucial to prevent sagging or detachment. Moreover, grounding the temporary poles and the messenger cable is essential for safety. When obtaining permits, provide detailed plans and specifications for the chosen method of temporary power connection. This includes the location of the poles or underground cables, the type of materials used, and the electrical load requirements. Be prepared to demonstrate compliance with all applicable electrical codes and safety regulations. Inspections by local authorities may be required before and after the installation to ensure compliance. Failure to obtain the necessary permits or comply with regulations can result in fines or the disconnection of the temporary power supply. When calculating the cost of each option, include all expenses such as the cost of materials, labor, permits, and any necessary equipment rentals. Obtain quotes from multiple suppliers and contractors to ensure you are getting the best possible price. Consider the long-term cost implications of each option, such as the cost of maintenance and repairs. The potential for delays and additional expenses due to unforeseen circumstances should also be factored in. When working with electricity, always prioritize safety. Wear appropriate personal protective equipment, such as gloves and safety glasses, to energize the circuit before making any connections or repairs. Use properly insulated tools and equipment. Follow all lockout/tagout procedures to prevent accidental energization of the circuit. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Remember that temporary power connections are intended to be temporary and should be removed as soon as the permanent power supply is available. Regularly inspect the temporary connections for any signs of damage or deterioration. Promptly repair any problems to prevent safety hazards or power outages. Keep accurate records of all temporary power connections, including the date of installation, the location of the connections, and any maintenance or repairs performed. This information can be useful for future reference and for ensuring compliance with regulations. In addition to the above considerations, it is also important to consider the environmental impact of each option. For example, underground connections may require excavation, which can disturb the soil and vegetation. Aerial connections may be visually intrusive and can potentially interfere with wildlife. Choose the option that minimizes the environmental impact while still meeting your power need. To reiterate some important points, firstly, always contact the power company to explore the possibility of a temporary underground connection. Secondly, if underground is not feasible, consider the aerial temporary service drop cable option. Thirdly, ensure that all temporary connections adhere to electrical codes and safety regulations. Fourthly, obtain all necessary permits from the municipality or local authorities. Fifthly, carefully consider the cost of each option based on materials, labor, and permitting requirements. Sixthly, contact a licensed electrician for advice and assistance throughout the process. For further clarification on electrical codes, it is worth noting that the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including temporary power systems. Article 590 of the NEC specifically addresses temporary installations, covering topics such as wiring methods, grounding, overcurrent protection, and disconnecting means. Consult the latest edition of the NEC to ensure that your temporary power system complies with all applicable requirements. Some specific NEC requirements for temporary wiring include using listed and labeled wiring and equipment, protecting wiring from physical damage, and providing GFCI protection for personnel. The NEC also specifies minimum clearances for overhead wiring to ensure safety. It is crucial to be familiar with these requirements and to follow them carefully when installing a temporary power system. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations that must be followed. These local codes may be more stringent than the NEC in some areas. It is important to check with your local building department or electrical inspector to determine the specific requirements for your location. Another important aspect of temporary power systems is grounding. Proper grounding is essential for safety and for preventing electrical shock hazards. The NEC specifies requirements for grounding temporary power systems, including the use of grounding electrodes and equipment grounding conductors. Make sure that your temporary power system is properly grounded according to the NEC and local codes. Overcurrent protection is another critical component of a temporary power system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from damage due to excessive current flow. The NEC specifies requirements for overcurrent protection in temporary power systems, including the selection of appropriate overcurrent protection devices and the proper installation of these devices. It is essential to ensure that your temporary power system has adequate overcurrent protection to prevent electrical fires and equipment damage. Disconnecting means are also required for temporary power systems. A disconnecting means is a device that can be used to disconnect the power supply to the temporary system. The NEC specifies requirements for disconnecting means in temporary power systems, including the location and accessibility of the disconnecting means. Make sure that your temporary power system has a readily accessible disconnecting means that can be used to quickly de-energize the system in case of an emergency. In summary, establishing temporary power across a street requires careful planning and attention to detail. Firstly, explore the possibility of an underground connection. Secondly, consider an aerial service drop if underground is not feasible. Thirdly, prioritize safety and compliance with electrical codes. Fourthly, obtain necessary permits. Fifthly, evaluate costs thoroughly. Sixthly, consult with a licensed electrician for guidance. By following these steps, you can ensure that your temporary power system is safe, reliable, and compliant with all applicable regulations. Remember that electrical work can be dangerous, so always take precautions and consult with a qualified professional if you are not comfortable performing the work yourself. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a licensed electrician or other qualified professional before undertaking any electrical work. In addition to the previously mentioned points, consider these safety precautions when working with temporary power. Never overload temporary circuits. Exceeding the rated capacity of a circuit can cause overheating, damage to equipment, and even fire. Use properly sized extension cords for the equipment being powered. Undersized extension cords can cause voltage drop, which can damage equipment and create a fire hazard. Inspect extension cords regularly for damage such as frayed insulation or broken connectors. Replace damaged extension cords immediately. Keep extension cords away from water and other liquids. Water can conduct electricity and create a shock hazard. Never run extension cords through doorways or windows where they can be pinched or damaged. Use cord protectors to protect extension cords from damage in high traffic areas. Be aware of the location of underground utilities before digging or driving stakes into the ground. Contact your local utility companies to locate underground utilities before beginning any excavation work. Use ground fault circuit interrupters, GFCIs, in wet or damp locations. GFCIs can detect ground faults and quickly de-energize the circuit, preventing electrical shock. Use caution when working near overhead power lines. Maintain a safe distance from power lines to avoid electrical shock. Be aware of the potential for arc flash when working with energized equipment. Arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. Wear appropriate personal protective equipment, such as arc-rated clothing, when working near energized equipment. Follow lockout/tagout procedures to prevent accidental energization of equipment. Lockout/tagout procedures ensure that equipment is de-energized and cannot be accidentally turned on while it is being worked on. Use caution when working in confined spaces. Confined spaces can be hazardous due to the lack of ventilation and the presence of flammable or toxic materials. Be aware of the potential for electrocution when working with temporary power. Electrocution can occur when a person comes into contact with energized equipment or wiring. In case of an electrical emergency, call 911 immediately. Remember, electrical safety is everyone's responsibility. By following these precautions, you can help to prevent electrical accidents and injuries. The decision between an underground or aerial temporary connection also depends on site-specific conditions. Firstly, consider the soil conditions for underground connections. Rocky or unstable soil may make trenching difficult and expensive. Secondly, for aerial connections, assess the presence of trees or other obstructions that could interfere with the service drop cable. Thirdly, evaluate the aesthetic impact of each option. Underground connections are generally less visually intrusive than aerial connections. Fourthly, consider the potential for damage from vehicles or equipment. Underground connections are less susceptible to damage from vehicles than aerial connections. Fifthly, assess the ease of installation and removal. Aerial connections are typically easier to install and remove than underground connections. Sixthly, consider the long-term cost implications. Underground connections may have a higher initial cost, but they may require less maintenance over time. To determine the appropriate size of the service drop cable and overcurrent protection, calculate the total electrical load of the job trailers. Consider the amperage requirements of all equipment that will be used in the trailers, including lighting, heating, air conditioning, and tools. Use the National Electrical Code, or NEC, tables to determine the appropriate size of the service drop cable and overcurrent protection based on the calculated load. Ensure that the service drop cable and overcurrent protection are adequately sized to handle the maximum anticipated load. It is also important to consider voltage drop when sizing the service drop cable. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or fail. Use the NEC voltage drop calculations to ensure that the voltage drop in the service drop cable is within acceptable limits. Furthermore, coordinate with the power company to ensure that the temporary power connection is compatible with this system. The power company may have specific requirements for the type of equipment used and the method of connection. Obtain approval from the power company before making any connections to this system. Regarding specific materials, for temporary poles, use treated wood or fiberglass poles that are strong and durable. Ensure that the poles are properly sized and installed to withstand wind and ice loads. For messenger cables, use galvanized steel or aluminum cables that are strong and corrosion resistant. Ensure that the messenger cable is properly tensioned to prevent sagging. For service drop cables, use insulated cables that are rated for outdoor use. Ensure that the service drop cable is properly supported by the messenger cable. For connectors, use listed and labeled connectors that are compatible with the cables being used. Ensure that the connectors are properly installed and tightened. When installing the temporary power system, follow all manufacturer's instructions and recommendations. Use appropriate tools and equipment. Work safely and carefully. If you are not comfortable performing any of the work, hire a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a licensed electrician or other qualified professional before undertaking any electrical work.